mix. And we also get octane. We shouldn't forget that ethanol is very important in bringing octane into the gasoline pool. So its profile is different to gasoline, and there are some downsides, there's some difficulties in the situation where you're mixing ethanol with a gasoline dominated infrastructure. So issues of water tolerance, the fit with the existing fleet, as I say, probably at its most important in the case of the US. And this issue of the concentration of ethanol that the existing fuel value chain can cope with, leading to a blend wall that the US is going to hit round about 2013, 2014. And so that takes us to advanced fuels, and I'm using the example of butanol here because here at BP we believe that butanol is an ideal choice of advanced fuel. Butanol is more like gasoline than ethanol is. It's got longer carbon chains, and that makes it more like a hydrocarbon. Very importantly, butanol and ethanol are mutually compatible, so we're not talking here about an either-or situation. In fact, our expectation is that butanol will be introduced into the fuel value chain alongside ethanol, and indeed as a retrofit product to go into ethanol-producing facilities in the future. What's important about butanol for us is that you can maintain all of those environmental benefits, the biofuel benefits that are accessible through ethanol. You lose a little bit in octane. We're talking here about the high octane isomers of butanol, but you get great blending flexibility, vapor pressure playing an important part there. A very good fit with existing fleets, and the ability to go to much higher concentrations in a non-modified set of cars, such as the US or Europe currently have. Water tolerance is very similar to the situation with gasoline, and so here we have a material that's easy to put down pipelines, easy to blend up the refinery, has a reasonable energy density, not as good as gasoline, but a reasonable energy density. All in all, we think it's an excellent compromise looking across all of the different properties of a fuel. So, in fact, we have a whole spectrum of possibilities. As we look towards future fuels, we can look at options around feedstocks, we can look at different ways of conducting our agricultural practices, massive scope to optimize and change processes. We can take choices within our processing, be that the agricultural processing or the conversion processing, to reduce the greenhouse gas profile associated with our activities. And all of these things actually play their parts in the economic competitivity of the fuel that we're making. And as we just discussed in the example of butanol, different biofuels bring different properties into the fuel mix, so different qualities of fuel. The point I want to make here is that for each of these different parameters, there's a spectrum. You've got choices, and the way that you put those choices together actually gives you a full biofuel system that can either be a biofuel done well, or indeed you could make a set of choices that lead to a biofuel done badly. And I think it's worth saying here that in the last 24 months, biofuels have come under some degree of pressure and criticism from some quarters. Much of that, I would say, not justified, because here at BP, we're quite convinced that it's more than possible. It's actually very practical to do biofuels well and to make the choices that actually lead to win-wins on environment, economics, fuel performance. So sustainability is indeed important in everything that we do. I don't propose to go into all of the different factors that are involved, but we do believe that sustainability should be central to development of biofuels, particularly given the pace of development, the scale of development that we're looking forward to. And so we're very supportive of both reporting schemes and certification standards that will help to demonstrate that as an industry we are indeed doing our job well and making the contributions that biofuels are capable of making. We're engaged, for example, in a number of round tables and things like the Better Sugarcane Initiative. In our view, that's really the right way to take these issues. So what are we actually doing at BP? I guess everybody's aware that we're working with DuPont in the development of advanced biofuels. And the first product to come out of that collaboration is indeed biobutanol. Biobutanol addressing three key challenges. Most importantly, it deals with this issue of the blend wall, not a Brazilian issue because of the predominance of flex fuel vehicles, but very much an issue in the US and a looming issue in Europe as well. It brings energy density and it brings a whole range of value propositions through the flexibility of the molecule at the refinery and the choices that can be made around its use in the infrastructure. We're working on biobutanol at the moment based on corn. We're working on it from wheat starch, and we're also working on it from sugar cane. So we're actually looking at a variety of different biofuel feedstocks. And of course, it can also be made from lignocellulosic materials. I'll talk a bit more about that in a moment. In terms of progress, at present we're constructing our demonstration facility. We're making good progress with DuPont on the development of the fermentation organism, and at this stage we've well exceeded what might be deemed the conventional benchmarks for production of biobutanol. We expect to be bringing biobutanol into the market by 2013, and we will be doing that by retrofitting ethanol facilities to show the ability to retrofit, because we believe that will be a significant entry route for biobutanol into the market. We're also working on the feedstock side, and there, as we've heard from other speakers, lignocellulose as a feedstock seems to be the critical path forward. We're doing that through a collaboration with a company in the US called Verenium, and we're working with a range of energy grasses, including energy canes of the type that we just heard in the previous presentation. Our partnership is operating at the moment a 1.4 million gallon demonstration scale facility, and we're using that to provide the design data for our commercial plant. Our first commercial facility will be in Florida. It will be a 36 million gallon production facility based on energy cane, and the land for that is actually in Highlands County in Florida. And we're expecting startup of that facility in 2012. So although we're talking about future possibilities here, actually the future isn't so far away now. Some of these advanced possibilities are really quite near term. We shouldn't forget, though, I said at the beginning that this concept of generations is in a sense a little bit misleading, because we're also investing in sugarcane, what's conventionally called first generation ethanol. But in fact, the performance, the economics, and the environmental credentials of this route are pretty much as good as the lignocellulosic routes. And this is an industry that has a lot to be proud of. So I think it's really important that we don't get hung up about first generation, second generation. We actually think of more the paradigm of biofuels done well, biofuels done badly. And sugarcane is a great example of one of the ways to do biofuels well. We can get greenhouse gas reductions of a very high degree, not least by being able to use the bagasse for power generation, or indeed in future for lignocellulosic conversion as well. So, to conclude then, if we look forward at what BP is going to be doing in the future, we're going to be doing a mix of things. We're going to be using sugarcane ethanol in Brazil. We're going to be investing in that. And we're going to be producing butanol ourselves. We expect to be licensing butanol into the market as well. And also introducing lignocellulose through the vehicle of energy grasses, introducing lignocellulose into, first of all, the US, but then in future other parts of the world as well. And bringing together eventually lignocellulose and butanol into a single process. So that's all I had to say. I'd just like to say thank you to everyone for listening. Thank you.
Nós vamos recolhendo as perguntas da plateia enquanto eu faço uma perguntinha extra aqui para o Ian. I have a question for you.
Okay.
Ian, with the knowledge that you have today about your process and the way it's evolving, could you make an estimation of what would be the investment in an ethanol facility versus a butanol facility? Would be the equivalent in terms of cost, or they would be considerably different?
Okay, so it's a good question. So our butanol activity, we've set ourselves the technical goal of producing butanol at the same price for a given feedstock, at the same price per joule as ethanol. So if it's sugarcane as the feedstock, we would be able to produce equivalent amounts of energy via butanol and ethanol at the same price. If it was a brand new facility, the capital cost of the facilities would be pretty much the same, actually, because there isn't really such a difference between the processing facility. The difference is actually predominantly in the microorganism used for the fermentation. But of course, if it's a retrofit, then you would be making changes to that facility, and it's probably not appropriate for me to speculate on retrofit costs at this point.
Ian, once ready, would the technology be deployed worldwide by BP, or you believe it would be, faster adoption in a given part of the world?
Our plan is to, so we're commercializing this through a joint venture, the butanol technology, through a joint venture with DuPont. And the plan is to convert existing ethanol facilities using different feedstocks to demonstrate the viability and also to give us our own production base. And we'll continue to invest in butanol facilities from there onwards. But in terms of licensing, we would expect that to be a worldwide activity, yeah.
Okay. Thank you very much, Ian. Bom, pessoal, a organização